Hi, so welcoming all. Today I'm more excited to bringing in this topic for you all. So today's our topic is what is precast elements. So we all know precast in today's scenarios and today's construction field. It's booming like anything. It's overtaking the conventional system, especially in terms of maybe it's reference to the conventional system, commercial buildings. Any commercial building which just consider if you want to complete the project by means of maybe of 5 years in the advance of in the precast technology, we would be able to achieve at least maybe 2 years, so we can save the 3 years span. So in this matter, in this scenario, this precast technology is booming in today's construction field. So in this today's topic we will discuss what are the types of elements and what are the advantages, how the safety measurement has to be taken care while installing the precast elements, and what are the standard practice IS course has to follow at the sites. So I'm here to just to talk about all. So myself Frank, I'm a civil engineer having an experience more than half decades in the construction field, especially of conventional and of precast. So let's start our concepts one by one. So earlier also there are so many elements which we were going to produce in the factory and which has been transferred to the site. So there are except footing we will cast everything in the factory and has been transferred to the site. So let's talk about what are the elements which going to cast in the factory and has going to transfer to the site. So first thing we are just using column, correct, and the next one we are just casting in the factory is beams, and the next is slabs, next is wall, and the next is facade panel, next is OHT or any tanks which comes on the terrace level. So let's talk about on the column itself. There are column, we will say, I'm just taking an example of 1 meter by 1 meter say column, say 1 meter by 1 meter column I'm taking here. So in this column, I'm just writing this in this manner. This is called as column, correct. I'm just writing this way. So in this patch you are going to find the corbel, correct. In the corbel, which is projected on either sides, it comes on the back side also, so that it is going to rest exactly above it as a beam. So beam will going to beam will going to rest over it. This is called column. So wherever the column which is casted in the factory, which has dowels which left for other columns which comes above it. Even meanwhile, even in the bottom of the column you will find the dowels holes which LD of. So this is LD length, which you have the chances of going to see the holes which kept in the below of the column, correct. This is actually meant for just to insert the column into the footing. Maybe I'm just writing the footing here, correct. I'm just writing the footing, correct. So this is as footing, correct. So in this footing, in the initial stages, where the casting, this is going to happen usually in the casting side, so that while the time of the casting, we are going to leave this dowel for the column which going to come above the footing. So this is how the column will go to cast in the factory and has been going to erect in the side. So next is beams. In the beam section, beams, you will find there are two types of beams, one is precast beams and another one is pre-tension beams. pre-tension beams. So in the precast beam is nothing as usual. We will going to cast some span, maybe of L span. We will going to cast and going to directly erect into the site. So in the pre-tension, we will going to see some, say for example, we have this kinds of span, L span we are going to have, correct? So in this span, we are going to have this tendons which runs in the beams, correct? So in the casting time itself, they have made the tension, so that you will find apparently going to find these kinds of deflection in the beams when it get loads, or when it has the slabs which comes above the on either sides of the ledge. It can settle exactly, become the straight, correct? So this is how the beams comes, or beams going to be casted in the factory. And even on either side you will find the development length, and on either side we are going to find the development length which gonna be which gonna be comes above exactly on the column, correct? So this is how the column, correct? This is column and the beam junction will going to apparently meets exactly the single points. This is column dowels, and this is beam dowels. So the another side also the same pattern will continue, correct? So even in the beam section itself, we are going to see there are like fully casted and the half casted beams. There are like fully casted beams and half casted beams. Like when the mode of transportation, say for example, usually in the construction field of precast technology, because of heavy weights, because every element has more than, because conventional system, because right. So in that particular situation, we will use the more capacity cranes we are going to use, so that accordingly we need to plan, or we need to produce the element. So we can't able to go beyond the crane limits, which we can't able to erect. So this is that the majorly the reason is half cast and the full cast is majorly as considered. Wherever there is a beam of particular, say I'm just taking this as a beam, say for example this weighs of around 10 ton, I can able to fully cast in the factory and I can able to transfer it to the site. So maybe if it's around 20 ton, I can't able to cast exactly in the factory, and I can't able to do erection at the site. So in that particular situation, we will half of the beam we will going to cast in the factory, and the rest of the half we will going to cast in the site, or maybe in the erection site. So that is there are other categories which comes here. So yeah, the next is so slabs. There are different types of slabs. What our earlier information is solid slab and hollow core slabs. In the solid slab, we gonna cast half in the factory, and rest of the half gonna be gonna cast in the in situ method, by means of because we need to run the some of the conduits, electrical conduits and other plumbing fixture. If anything is to be installed in this particular, we have around 3 inches of gaps according to the design, so that we are in this the leftover part we will just gonna cast in the in situ method. The next one is hollow core slab. So in the hollow core slab, I'm just taking a section of this, correct? So if you cut the hollow core exactly here, see it's around 1200 mm max. I will be there. This depth is varies from 100 mm to 400 mm, correct? So you will find the holes in the slabs through and through, exactly from this end to that end. So here you will find the tendons, pre-stressed tendons. Especially the consideration has taken in such a way that the hollow core which are used are casted is of M60 grade or above, correct? So these kinds of slab we are going to see in precast elements. One is solid slab and a hollow core slab. So next topic is called the walls. So next is wall. So in the wall we come across with solid wall. Next one is called double wall. Solid wall is nothing but, as usual, it's a pure solid. Say for example, this is of panel. I'm just writing an elevation of thickness of say called 200 mm with bottom provision for the dowels just to insert, correct, just to insert from the footing, and above you will find the dowels which protruded just to give that which is which is extruded from the top just to have the development length for the element which comes above it. So next is double wall. So double wall we will use especially in the retaining wall. So double wall, if I am just taking the cross section of double wall, cross section I am taking, okay. So in this double wall you will find in between lattice girder will be there, correct. So this is called lattice girder. So double wall, this is entirely a purely double wall of maybe of 300 mm. This is going to be very, say for example some roughly we can say called around 75 mm will be there on either side, 75 mm. So in this double wall it's clear that there are two solid panels which are joined with the lattice girder, okay, and casted in the factory, which has been brought into the side and has erected in the footing, correct. You will find the dowels from the footing. So in between this gap we need to fill the self compacting concrete or any which is flow is very because this double wall has to be taken care of, especially that we need to pour the concrete layer by layer. So we need to fill up to the top. Suppose if there is any double wall which is coming above, we need to leave the dowels in prior to before casting the final layer. So these kinds of wall we will going to see in this. Yeah, the next is facade panel. So facade panel are usually architectural view which has casted in the factory and has been transferred to the side and has erected. Maybe of any design kind, say some of the panels which have these kinds of grooves which are made in the factory and which has been erected in the side. The same way in the OST. OST is simple as usual in the overhead tanks. Maybe of you will find the ready-made factory tanks which has been directly bottomed up to the site and has been directly erected in the site. These are majorly, there are 6 categories, 6 elements which majorly we use in the commercial buildings, especially with respect to the precast construction technology. That is columns, beams, and the slabs, and the walls, and the facade panels, and the OST and the tanks, correct. So next is why we need precast technology. We would have been done with this conventional system, so why we have opted it. There are advantages we are having. So advantages. What are the advantages of precast technology? Why we need it? So majorly is it saves the time of construction activity. Because in the conventional system, suppose you want to construct a building of commercial G+10, it would have taken around maybe 5 years. You can same project, same specification, you can get it in around max of 2 years, correct. So it saves the time. The next is quality assurance. So because it has been every element which has been casted in the factory in a controlled system, so that the quality of product which is got produced from the factory is high end. So there is no compromisation in the quality. And the next is cost effective. Cost effective. So because the same panel which we're going to use for in the factory, which has been repetitively more and more, because so that if you consider that because we are going to do in the factory, consider it in a closed environment, so repetition of maybe shuttering item materials or maybe which is used for the making of elements or repetitions will going to be more, so that we will go have the less cost. So next is cost. Yeah, the next is we have seen is aesthetically aesthetic view, because the amount with which the elements which are produced in the factory has very fine product which gives a very good impression, so that you not at all required any plastering about the, hence it avoids the plastering also, correct. So even manual is the being advantage, some of the disadvantage also will be there. So let's talk about all. So disadvantages, what are the disadvantages are there, correct. So maybe you can say because of heavy in the weight, so it includes transportation charges includes, even transportation charges includes, and even mode of transportation while transferring the while transporting the elements from one factory to the site, there may be chances of damage, there has a drawback here, and even it requires huge investment, high initial investment required, high initial investment has to be also required. So yeah, because the majorly we need to have these kinds of a big structure, big elements, we require purely satisfied big factory which requires to be set up in the very particular designated area of its, maybe if in the acres, maybe our 30 to 40 acres definitely we require, maybe of having the factory in the production department and the stacking yard and the loading bay. There are so many constraints, so many departments, so many various of areas which has to be designated in the factory, because it requires huge investment. So high initial investment has to be considered, correct. So these are the advantages and disadvantages majorly when you are just looking as a precast element. Say for example, if something which quality violation or maybe damages which has happened during the transportation, that entirely the element is going to be waste, that's going to be huge depth, well maybe of transportation, correct. Suppose if there is any going to be damages which happened or which caused, correct. So while installation is every individual elements has their own methodology and own safety consideration has to be taken, because these elements are weighs more than in a tons, correct, because it weighs in up to 10, 20 to up to 18, there are it varies according to the elements. So there are every element, as I said earlier, every element has their own particular methodology, we need to follow that. Safety is utmost, because precast site is a more prone to the safety hazards, because we need to take safety utmost, especially in the precast site. So while considering all together, we need to complete the projects with very good and good manner and good quality assurance, so that you can get the profit and can deliver the project in on time. This is all which you are going to add your precast project. So nowadays wherever you see precast technology is taking more fast compared to the conventional system, because it saves the time and the quality and cost. These are the makes construction is even still more fast compared to the convention. So that's all my topic today. So hope this video this is quite informative for you. I'll try to bring the same kinds of content in the upcoming session with ending with credit regards and thanking you.